who of you has ever heard about WinCC Open Architecture? Just raise your hand. And Siemens people do not raise their hands. Okay, not that much, but that is good. It gives me the opportunity to give you a brief introduction into WinCC Open Architecture and also why it fits perfectly into UNS and how it can very good talk to MQTT. So let me first start with a quote from Walker Reynolds, what he has said at the Proof It conference. I think some of you will have heard of that. So he said at the Proof It conference that most people think of WinCC OA that it is SCADA plus, whatever he meant with plus. But he said it is not. It is a rapid application development environment. It's a platform for solving problems. It's an IoT platform. And to be honest, I fully agree with him. So I hope I can also show to you that it is an IoT platform, not only a SCADA. So let me give you a short introduction how WinCC Open Architecture works and how it is constructed. So already 30 years ago, we decided to build our SCADA system based on a microservice architecture. So that means we have multiple components and all of them are connected or communicating via TCP/IP. So in theory, you can also place the components on different servers. And the very important one is in the middle. The yellow one, it's the event manager. And this one is very, very similar to an MQTT broker. So what it basically does, it is distributing managers from our components. But additionally, it also keeps the current state of our tags in the system. And then on the bottom, you see the drivers, and those drivers are responsible to get the data in from a lot of different devices. They bring the data into the event manager. And on top of the event manager, you see processing control. It's the layer where you can implement your business logic. And there you can use either our own control language. And this is very, very lightweight, easy C, let's say, without pointers and all that complicated stuff. But you can also now use Node.js. So you can use JavaScript to build your business logic. And with that one, then you can leverage the full power of the full ecosystem of Node.js. And what is also missing here is that we also have integrated Node-RED into WinCC OA, so you can also use Node-RED to create flows based on the data in our system. And on top, of course, user interfaces is all of the time part of a SCADA system. So we have user interfaces which can run natively, but it can also run in a browser. And also we have additionally a dashboard where you can build easily nice-looking dashboards. So let me now come to a little bit to compare WinCC OA and SCADA to MQTT and Kafka. And this is not about competition. Yeah, I think the technologies are complementary, but I think it's still important to know the differences. So then you can also, it's good to know when to use what kind of technology. Yeah, and so in WinCC OA about data storage, and I really loved what Marco Donovan has said before. Yeah, the very good thing in MQTT is that it is data agnostic, so it just transmits bytes. But the bad thing on MQTT is that it is data agnostic. Yeah? If you compare that with WinCC Open Architecture, there we have structured data. So you define your plant, you define your machines, you define the structure, and so we have a semantically hierarchy in WinCC Open Architecture. And also that one can then be exposed to MQTT, what I will come to later on. And also important for me is always also to say, we also have always the last well-known state of our tags, of our machines. And with that process image, we are also able to query the data. So we are able to say, okay, give me the current state of the machine. And why is this important? Of course, if you build an HMI and the operator opens a screen, then he wants to see immediately the current state. Yeah? And as you might all maybe know, MQTT here is different because it is only transmitting value changes. So if nothing happens, then the client, or let's say it in another way, it is not possible to say to the broker, hey, give me the current or the last state of the topic. You have to subscribe to it, and then you have to wait until the value changes. And that's the point. I mean, okay, you may also know there are also retained messages in MQTT which you can use, but even then you have to subscribe to the data. There's no query option in the protocol. And what I want to say, I wanted to add here also, because some people are saying, okay, then I will put all my data as retained messages into the broker. I would say be really careful before you do that, because recently I also did some tests with retained messages, and the broker's behavior is different. Not all have the same behavior with retained messages. For example, some are writing the messages only periodically to disk in the default every 30 minutes. So that means you cannot really rely on that the data is really already written to disk. And if the broker crashes, then maybe you lose data. So don't use it as a database, I would say. And if you compare it with Apache Kafka, in Apache Kafka, I'm not sure how many of you know Apache Kafka? Still a lot. Okay, then there's no need to talk a lot about it. So there we have the stream of the data, so it all the time writes the data to files. But also here it is a streaming technology. Also here we do not have a current state, let's say. You also cannot go to the broker and say, give me the current state of the machine. And also what is important in Apache Kafka, because every single topic is a file on the disk. So don't try to, let's say, map what you have in SCADA systems. If you have there 100,000 properties, 100,000 metrics of your machines, and if you will map every single metric on a single topic in Apache Kafka, then you will, that the broker, I think, will get broken. Broker will get broken, interesting. Because in Apache Kafka that will end up in minimum having 100,000 files on disk, written on disk. And Apache Kafka is not made for that. Apache Kafka really shines where you have a high volume, high throughput, but less topics, let's say. Connections. In WinCC OA, or generally in SCADA systems, we typically have a limited amount of connected clients, let's say. So we have a limited amount of connected machines. We have a limited amount of user interfaces which are connected to the system. And in the case of WinCC OA, I think you can connect up to 4,000 clients. In MQTT, this is different, and here shines MQTT. You can use an MQTT cluster, for example, -Q in the cloud, and then you can scale this out cluster so that it can handle millions of connections. -Q all the time has this use case of connected cars, where you have millions of cars out there, and they are all connected to a broker instance in the cloud. Of course, then it must be clustered. And in Apache Kafka, there we also typically have more in the area of thousands of connections. So a little bit about packet size. Let me start here with MQTT. So imagine you have a machine with 100 metrics, and you want to publish these value changes of those metrics on separate topics in MQTT. Then you must execute a publish 100 times with that metrics. And in MQTT, that leads to that every single publish is sent on the wire. So every single publish command is creating a packet on the wire. And that is really important, because if you have high frequent data, then this can really lead to, or it leads to having a lot of round trips between the client and server. And this is, of course, not really very efficient. And what happens then? You may tend to put multiple metrics into one payload and put it on one topic. For example, Spark B is exactly doing that. That's totally fine. But you just need to know, or it is very important to know, when you do that, then you lose the ability from the subscriber's point of view to just subscribe to a single metric. And now imagine you want to build an HMI where you want to visualize only the current state of maybe 200 machines. What happens then? You must subscribe to the topic of the 200 machines, where you will get all of the data of the machine. Even if you're not interested in it, because you only want to have the state. But then you have to filter the state out on the client. So you're moving a lot of data without any need. So also here, same what Mark said, you have to think very carefully how you you build your topics, how you build your topic namespace, and how you use the payload. Yeah. So at the end of the day, obviously, I will say that HMI is made, SCADA systems and WinCC Open Architecture is made to build HMI for that one. It is really perfect. In MQTT, it depends how you have structured your data. It can be good, but cannot be good. It depends. And Apache Kafka is also not really good, because also here we typically will see more that we put all the data of a machine, or maybe even the data of one production line, and put all the data on one topic. Yeah? And also just a note, Apache Kafka really shines when you have a lot of data, and they create very, very good packets, and you also have here the option to compress those packets. So if you send data to the cloud, for example, I think Apache Kafka is also a very good way to go. But even though sometimes, recently I have again heard that Apache Kafka, the cloud native SCADA, yeah, I mean, that's ridiculous. Yeah, Apache Kafka is far away from being a full-blown SCADA system. Yeah? And don't misunderstand, I really love Apache Kafka, it's really great. For data streaming, it's really cool, but it is not a SCADA system. So, data historization in WinCC OA, we also have included let's say an historian, so you can write your data, your tag value changes into different databases. In MQTT, it's not included. This is maybe, it's not included in the standard, let's say, in the MQTT standard, but of course, broker vendors have add-ons which also enable that, so that you can historize the data into databases. But also here, then again, you have to deal with the unstructured data. So the data, what is written to the database, the one who will read the data from the database must know what kind of data is stored in this, let's say, payload and binary stuff. In Apache Kafka, there we have streaming technology, so that means we basically all the time have automatically also the history of the data. And also what is very cool with Apache Kafka now, at least with Confluent in the cloud, they are now starting to automatically transform data streams into Apache Iceberg tables. So then you're also able to query the data, which is a quite nice feature, I think. So what are the challenges for an IoT platform? Well, it's about connectivity, getting data into it, about data integration, transforming data, also scalability matters, and of course security all the time matters. Just a rough overview. With WinCC Open Architecture, we have a lot of options to do southbound connectivity. We have a lot of drivers to different protocols, to different devices. I will not go into detail here. This should just show that we have a lot of options to connect a lot of things to WinCC Open Architecture. And the same applies then to the northbound connectivity. So here we see in WinCC OA, we are, as the name also says, open. We have an HTTP server. We can deal with REST interfaces. We can get data into with REST API calls. We have also Node-RED integrated. There are also even Node-RED, nodes available for Node-RED at FlowFuse, I think, also there, where you can then get data directly from WinCC Open Architecture and use it in Node-RED. Of course, we have OpenCUA, Modbus. I'm not really sure why Modbus is on this slide for northbound connectivity. I would see it more for southbound, but anyhow, we can connect to Insights Hub. This is a Siemens tool to get insights out of your data. And of course, we see here now MQTT and UNS. This is maybe the most important for this conference here. In WinCC Open Architecture, what we also can do is we have our tags, and we have our structured data, so semantically organized, but still on top of that base data, we can create an additional view, and not only one view, we can create multiple views with, again, an additional hierarchically structured way. And that view can then be taken, and with our MQTT publisher, we can say, okay, I take this view with the full structure and I plug it in, let's say, into MQTT, into maybe an existing UNS, or maybe you create the UNS with that one. So, and I will show that afterwards as well. And also we can get data into WinCC OA from databases, relational databases via ODBC. I personally have done in my former days, let's say, a lot of projects where WinCC OA has been used really also as a MES system. So it was used at the office and they did the planning, and behind the scenes we have very heavily used relational databases. In that case it was Oracle. And then we are doing the planning there, and then really the same system goes down to the shop floor where the operator then executes the production orders. So data integration. So here we cover the full stack of connect, collect, store, visualize, and analyze. Yeah, we are getting the data in. On the right side, you see with our drivers. And also these drivers are already very important because they are getting data maybe from a PC, maybe by polling, so polling every 100 milliseconds or so. And then the first thing what it should do, or must do, let's say, it transforms this polled data into event-driven data. Yeah? Because as said, WinCC Open Architecture is fully event-driven. And also the drivers can do some simple conversions like converting raw values to engineering values. Also what Mark mentioned before, so that we convert maybe from Fahrenheit to grad Celsius or so. Yeah. And that is also important. I forgot to note about the structured data in WinCC OA. We also have additional, let's say, field and information on the tag. So we have a description, yeah, multi-language. We have a unit, yeah, we have maybe a value range, and so a lot of context information we also have there in the system. Data historization, yeah, I just wanted to mention here, we have the option to log data into an influx database, into a PostgreSQL database. Also timescale will come here soon, and also to Oracle database. And additionally, if you want to have another database, then we also here have an open API. So if you have programming skills, then you can also program your own. We call that backend for our logger. And then you can also write data to other databases as well. So a little bit about scalability. So WinCC Open Architecture runs from very small and constrained devices. So it can start on an IoT 2050, but also on a Raspberry Pi. And I personally had WinCC Open Architecture running 10 years ago on a Raspberry Pi. And you may know 10 years ago, a Raspberry Pi was really not as powerful as it is now. So it was really more constrained. Yeah? And of course, then it can also run up to servers in the data center. And yeah, WinCC Open Architecture also runs on Windows, on Linux, and also in a Dockerized environment as a container. So redundancy, yeah, as a SCADA system, redundancy is more or less a must-have. So we also have redundancy. Additionally, we have also a disaster recovery system, so you can connect two redundant systems together and really replicate the data from one data center to another one. Hierarchically connected systems, we can also connect multiple WinCC Open Architecture systems together. We call them then distributed systems, and that is how we scale out. Yeah, and one example is shown here. So we can have on the different production lines. Yeah, we have one system for every single production line, and then we connect them together for a top floor management system, which is also WinCC OA. And on the top floor, you can then visualize and also analyze the data which comes from the shop floor. And also important here to notice that we are only transmitting that data in which the head system is interested in. So we don't transmit everything. So security, I will not go into detail here. It should just show that we have a lot of certificates within this open architecture. And yeah, it is a secured IT/OT platform. So WinCC OA in action. So I will try to show you now something a little bit. And also, good to know, you can register for free and download it for free. And then you can also use it for free. It will run for 13 minutes and then it will restart. So it is free to use, free to experiment with it. So now coming to a little bit of demo. I hope it will work. So what I have here is, so on the left side, on the bottom side, you see Austria, a MQTT publisher. So this is my home. and smart home, which is effectively not really very smart, but we have here some temperature sensors, a photovoltaic system, also some power meters, and I publish that ones to a central in the cloud running MQTT broker. By the way, this is my own self-made MQTT broker, the Monster MQ. Yeah, and on the right side, then we have here my PC, and we are running WinCC Open Architecture here, and then we can get the data from MQTT into WinCC OA and then visualize it. That's one part. And the second thing is the little robot here is, it is the thing of the IoT, which is connected in that case via Modbus TCP to WinCC Open Architecture. And also here we see we're getting the raw values in. We have to do a little small, very simple math calculation to transform these raw values to milliradians, so the position of the joints of the robots. And yeah, and then we can publish that data via Spark-B to MQTT in the cloud. And then on the top right, I additionally have a Unity 3D application. So it's Unity 3D. Who of you knows Unity 3D? Yeah, also it is some. Okay, good. Yeah, it's coming from the gaming area, but it also is nowadays heavily used also in the industry. And with that one, we can then visualize the robot, the current state of the robot as a 3D model. So it's like the live digital twin. And yeah, and because the conference is also all about AI, everyone has to talk about AI. So I started in a quick manner. I have used a large language model. So from in that case, Google Gemini, and I really did that in one day. So I have just used Gemini. And here again, I take the information what I have in WinCC Open Architecture, and there I have context information like a description on my tags. And I've just written somewhere, this is the power of my house and so on, description, units, and that things I can query. Yeah, when some operator creates a prompt, then I query the current data from WinCC Open Architecture, give that data as a context to the large language model, and then the operator can ask questions on that data. Yeah. I mean, for sure, this is a very simple thing, just RAG, retrieval augmented generation, let's say. And of course, this cannot be done in that way. If you have 100,000 metrics of your machine, then this will not work. But for the simple use case, and as I said, I really did this in one day, so it was very easy to integrate. Here you see WinCC OA in action. So on the left side, you see, it's the tool. With that one, you can start the project, you can start WinCC OA, and here already you see the managers, what we have. And every single manager here is a separate operating system program. And yeah, and here in the middle, you see, for example, how I can configure a connection to an MQTT broker. You see here, in that case, I'm using WebSockets. At least the communication is secured, but there's no username, your password. My broker is completely open, and please, also you can use it. Yeah, it's hosted somewhere in the cloud. You can use it for free. And yeah, that's basically almost all what we first have to do. And also here we can, of course, create multiple connections to multiple brokers. That's also possible. And then all what you have to do afterwards is, here you see one of the engineering tools where we see the tags what we have, and I have created here one home automation tag. And you already see that also here we have the option to create some kind of a hierarchical structure. I did not do a lot, but you can do that however you want to do it. And then at the end of the day, we have here tags, where the data lives on, and here we have a float tag. You see already here, when I hover over it, then you see already here a comment, which I will also then use for the large language model. And how to get data in from MQTT to this tag, it's very simple. You just have to add here, we call this address config. And then you can give here the topic name and the transformation. Here you can also choose, maybe you have a JSON on it, then you can also interpret the JSON. But in my case, I made it simple. I have just a plain value on the topics. And then the manager will try to convert the string, of course, to a float. And that's basically all. I mean, of course, to do this with every single tag is maybe a little bit a pain, but what you all the time can do, also you have some kind of a mass engineering tool where you can export the data and then have it in a spreadsheet, and then you can do configure it in a spreadsheet and then import it again. So this is the data what comes from my home, and yeah, the data then I've included in WinCC Open Architecture and written. Then they are written on tags, and yeah, then I can create this visualization. Now let's try out. Let's try out the large language model. Let me think about the question. Which rooms have the highest and the lowest, or which room has the highest and the lowest temperature? In theory, there should also be a voice output. I don't know. When I connected everything, it worked. No, it doesn't work. But anyhow, you can see the answer. So it will tell me what is the room with the highest and the lowest temperatures. And what else can I ask? Are there any pumps in the system which have a male function?
The highest temperature is in the outside room, 26.36 degrees Celsius, and the lowest temperature is in the basement.
That was the answer from the question before. Okay. Yeah, interesting. Yeah, everything runs through my mobile phone, so maybe there's a little bit delay there. So, and yeah, and also let me show how to publish data in a UNS style from WinCC Open Architecture to a UNS. And so for that we have here our plant model editor, and here I can create a model, and in that case, again, very simple one, just German, Munich, WinCC OA, and here then we add as leaves our data points, So, where did I stop? Yeah, how to publish this to a UNS. So all what you have to do is create your model, and also here again you can create multiple views on it. It points to the existing data in the SCADA system, and then we can publish that to MQTT broker. And what I have to do for that is I will start here now this MQTT publisher component. And let's first open the so when I start it now, then you will see here a new node, and then all the data what I have defined in this tree is getting published to the UNS. And here in that case, we have a JSON where we have value, time, and status. So this is very easy. So the next one, let's try out the robot. So as said, I have connected the robot via our Modbus interface, so we will get the current state of the robot, also again on tags. And here we have the, let's say, the original input. I named it in that way. And you see already here we have negative numbers. They look a little bit strange. And all what you have to do in WinCC OA, we create another tags, and then by having we call that a data point function, and with that one you can create very easy, simple maths to convert this value to another value, and then we will have the values, let's call it engineering values here, again on this tags, and then what we can do then is also publish those values as Spark-Plug B messages. So I have to start here a manager. And by the way, this Spark-Plug B, in that case, this is just a proof of concept what I have done with Node.js. And again here, I've just used the existing Node.js libraries for Spark-Plug B and have used it with WinCC OA together. And but Spark-Plug B is also on the roadmap, so there will also come a native driver for Spark-Plug B to get data in and out via Spark-Plug B. So, and once when I've done this, let's see. So then we have here, first we got the birth message of the Niruro 1. This is the robot. And here you see it contains the position of the joint. And after that, then we are getting data and data. And now let's check if the Unity 3D can get that data from the broker. So starting takes some time. And by the way, if you want, you can scan the QR code on your mobile phone, and then you will get the Unity 3D application running in the browser, and then you will also have the 3D model visualize the current state of the robot. And again, we got the value from the robot into WinCC OA and publish that to the cloud, and then all over the world you can take a look how the robot looks like. So let's try to move the robot. So it's moving right. By the way, we have also integrated the 3D model of the robot in our SCADA system in the screen directly. But of course, this one is not getting the values from the MQTT. This one is getting the values directly from the system, of course. Yeah. So, by the way, if you start this little Unity on your mobile phone, then it happens that it is somehow like a little game, yeah, and you have this rocket, and when another one starts the game, then they have the same position, then they collide to each other, and if you are in that kind of position, let's say you have on the top right, you can press reset, then you will, yeah, exactly, then you will get back. So let's try to put this somehow together. It's a little bit not that easy with the screen. By the way, also I can control the robot with my voice. Let's try that out. So we have now here two visualizations. So this is the preview of the robot. So when I send a command to the robot to which position it should move, then we will first see it here, and only when we then execute it, then we will see it here, the real state, let's say. So let's start it again. Rotate your arm by 45 degrees to right. Well, it did not really turn right. So that's the behavior of large language models. But to be honest, I would not really use my voice to control a robot, but this was just a try to play around a little bit with large language models so that they really only give me the output of the joints and so on. Yeah. And then I can execute it, and then it will move. But we can also do a little bit of loop of movement. And it will, hey, someone is shooting on me. Interestingly, in my Unity application, I do not see the moving robot. I hope some of you have started the application. Oh no, it starts to move. Yeah. Again, maybe this is a connection problem. Yeah. So yeah, I think that was almost all what I wanted to show to you. So I hope you got a little bit an impression how WinCC OA as a SCADA system, but not only as a SCADA system, also as an IoT platform can be used to get data in and out from MQTT. So it's, I would say, perfectly fits to UNS and MQTT. So thank you.